Welcome back. This is Concept Development Practice page 25.3 on wave superposition. So if you have a wave, which is an energy, an energy traveling in a medium, so let's say it's air, let's say it's steel, or let's say it's a string or anything, or a spring, you've got energy traveling through it. What's going to happen is that if you have two pieces of energy traveling through the same medium, meaning that those waves will touch each other or interact with each other, you're going to see that waves will either cancel each other out if they're completely opposed, or they will add and make it louder. So if I have, for instance, a sine curve, so something like this, kind of wobbly, where you have an up and a down, anything that's up added with something else that's up is actually going to increase it and make it even more. So two waves, partial waves will add to each other. If you were to have something like this where you had a wave in this direction and a wave in this direction, they're actually going to cancel and you'll end up with no wave at all. It'll be perfect silence if it's sound, or blackness if it's light. So two sounds can actually cancel out. Two light waves can cancel out. That's why a laser is very strong, because they don't cancel out. They're only overlapped. Lasers are only overlapped. That's why they're so piercing. But a flashlight, the waves fight with each other, and some of the waves add together and make light brighter. Some of the waves will cancel each other and make darkness, which is kind of awesome. So let's look at this. Here's time equals 0. So this triangle is actually a sine wave, if you want to think about it, but it's easier to draw. At 1 second, okay, so you've got them here. They're at 0 seconds, and they're traveling towards each other. So at 1 second, they're one dot further closer together. Okay. At 2 seconds, they are one dot further closer together, which means they're a dot. So we'll look at the rest of the left in just a second. They're asking you to anticipate what would happen if you have opposite sides that are going to encounter each other. So what's going to happen? You're going to, in 0 seconds, they're going to be together. In 1 second, okay, here's where they are. Here's where it is at 1 second. So it's going to be one closer, okay, and this one is going to be one closer. So that will be at 1 second. What's going to happen at 2 seconds? They're going to go one more dot in. So this will be like this, and then this will be like this. They're actually going to touch. Now, once they touch, they're going to interact. Look over to the left. Okay, so at 3 seconds, what's happening? Well, as this one moves this way and this one moves this way, they're going to overlap each other. And what's going to happen is the two waves that are on one side is going to add together. So you're going to have something like this. Here it is in one. Here's the other. That means that these two things are going to be 1 plus 1, which is 2. Okay. This one wasn't added because it didn't have two above each other. See, this one has 1 from this side and 1 from this side, so it's going to be 2. So you end up with something like this. When they go even closer, they overlap, and you're going to get a additive wave. Okay, so what will happen on the other side? So on the other side, this is going to be one closer in. Okay, but this is also going to be one closer in. Now, what does that look like? Okay. What looks like is that I have to have one wave. These two things, this part right here is 0, and this part is 1. This part is 1, this part is 0. So they're going to essentially add together, and I'm going to get a connection between the 2 points. Okay, they're going to kind of meld together, if you want to think of it that way. Well, what's going to happen when you get to the next one? Okay, as it goes one end from here to here, you're going to have this one as, let me just do it as dots. Okay, so because you're going to see that one is going to be going left and the other one is going to be going right. Right, so do you see? So this one plus this one will cancel. This will cancel. This and this will cancel, and they all end up as a straight line. So if they add together, now so we're now at 4 seconds, so they've overlapped, but they're backwards of each other. If they overlap and they're on the same side, they're going to increase. They're going to double. So everything that was 1 is now 2, everything that's 2 is now 4. But if they are on opposite sides, they cancel. So if it's 2 on one side and 2 on the other side, then they cancel out to 0. Okay? So what do we anticipate at 5 seconds? Okay, so that means that we're here. This is going to go one direction, and this is going to go the other direction. Okay, so if I were to draw that, then this is going to be something like, this, and then this one is going to go one in, so it's going to overlap. Like that. And so it's going to be essentially like we saw this guy up here, where they're overlapped in 2 directions. And so they're going to be something like that, where you're going to have a wave that is not all perfect half circles. Okay, they're going to it's going to be an interesting shaped wave, more of a crazy kind of thing. So now we'll go even further out because we're moving away from each other. The one on the top is moving to the right. So now I've got a triangle here. Okay, the one on the left, the triangle is here. Okay. Oh, so it just overlaps perfectly. Okay, nice and easy. Then the last one is 7. I'm just going to move one more out. These are easy now, okay, because this is simply going to be, triangle here, and then it's separated, and a triangle here. So they're going to move away from each other. They're not going to disturb each other, but if they overlap at all, on the same side they add, on the opposite side they subtract. So now they make you do it yourself, okay? So you've got a more complicated wave. You've got a sine wave on the left and a sine wave on the right. They're going towards each other. What's going to happen? Okay. So let me do one at a time, and then you can stop the video and copy if you want to. But will you anticipate before I draw? Okay. Will you try to draw, and then you draw over your drawing? If it's right, awesome. If it's wrong, correct it, and then we'll just do one chop at a time. So here's 1 second. I've simply moved them in closer together, and you're going to see in the next second they'll touch. So why don't you make an estimation and keep going. You can stop the film on each time. Okay, I think this one was the easiest one. They've just moved together, and so now it's essentially one wave together, but they haven't interfered at all with each other. So again, we've got it to where it's overlapping slightly, and so you're going to have an adjustment. So the adjustment's going to be kind of a sharp rise here. If you've ever seen a voice print, like a person that they speak and you've got the lines, you're going to have lots and lots of very sharp rises and lowers, because these sounds that you're making from different parts in your face, your throat and your nose and your sinuses, are all overlapping each other and making a very distinctive voice print. That's why you can tell one person from another just by analyzing their voice. Okay, so what's going to happen here? You've got an overlap section where this is on one side of this side, and so what will happen is you will eventually erase this. This is all going to go away. This is all going to go away, and you'll end up with a flat line here in that section. Okay, so what's going to happen here? Okay, so let's look first of all at this section. You're going to have two that are on the same side, so they're going to double. So I've got one from one wave, the one from the other wave, so it's going to come down here to 2. So on this side, we're going to have a flat line. Okay, this is going to go away here. Okay, and you're going to end up with a flat line just on this side. Okay. And the same thing on this side. You've got a 1 to the top on this side, you've got 1 to the top on the other wave, so it's going to double to a 2. So this will be flat line on this side, and then the other, parts will go away. See if I can erase it. Okay. Okay. Now the last thing is I've got an overlap section in the middle that's going to do as we've done in the past, and you're going to get an over line here, and so you're going to get something like this. All right. So let's try to do number 6. So this one is the coolest. You've got 2 that have overlapped at top and bottom. That means that I've got 2 on this side and 2 on this side, so they're completely overlapped. So I have 2 at 2. That means that they're both going to double up to 4, and I'm going to have a 4 in this case. This is now constructive interference, where the sound sounds louder than it was because 2 sounds are identical, have come in and overlapped. Likewise, this is 2, so it's going to add up to 4 on this side, and you're going to get a very loud sound top and bottom. They're going to sound discordant, and then they're going to come together and be very loud for a second, and then as they move apart from each other, they're going to weaken again. All right, let's try 7. So can you tell what's going to happen? I've got here an overlap section here that's going to be straight line. Okay, and then I'm going to have an overlap section here that's going to cross in the middle. Okay, so whenever you have 2 on the same side, they add up, and so if you have 1 each, they add up to 2. If you have 2 each, they add up to 4. So you can see that this sound is going to be softer than the sound at 6 seconds. And then let's do the last one at 8 seconds. So the last one looks a lot like time 4 seconds, where you have an overlap section where you have a 2 on the top and a 2 on the bottom that are going to cancel out. So you're going to get a flat line. So this will be a sound print that looks like this, and then these 2 will go away. This will go away on this side. This will go away on this side, and so you have a kind of an area like this. So you can see that if you were to have an oscilloscope that's going to measure some kind of a energy wave that's interacting with each other, so either electrical waves or sound waves or light waves, where you can see it, you can see a print like a voice print. You've seen this on your voice recorder where you have voice prints. What's happening is the different sounds are overlapping, and that's what's making the very interesting shape of the print. Okay, great.